Hello and welcome to this UniTaster On Demand video where we introduce studying particular subjects at university. And I'm delighted today to be running a session on one of our most popular requests that we are receiving, and that's for an introduction to studying physics at university. I'm delighted to be joined by two brilliant speakers for this event. I'm joined by Professor Justin Reid. Justin is joining us from the University of Surrey and he's the head of the Department of Physics. I'm also joined by Dr. Caroline Shenton-Taylor. Caroline is also joining us from the University of Surrey, and Caroline is a lecturer in applied nuclear physics. With these events, we try and cover four main themes: why to consider the course, what to expect on it, application tips, and also an overview of careers. And I'm always very conscious that with these events, you've tuned in to hear from our fantastic speakers, not for myself. So I always keep my introduction very short. So if I pass it please to Professor Justin Reid, join us from the University of Surrey, our first speaker. Thank you.
Okay, thank you, John. As John said, I'm Professor Justin Reid. I'm head of department at the University of Surrey, and I'm joined by Dr. Caroline Shenton-Taylor, who's our lecturer and admissions tutor also at Surrey. And the outline for the talk today really is why study physics, and then you'll hear a little bit about what a physics degree might actually be like, admission tips, and career pathways. So let me start with why you might actually want to take up a physics degree. And I think there's several main reasons, but the number one reason, at least for me, is that physics is just absolutely fascinating. You'll get to study the entire universe from the very, very smallest things, the atomic scale, all the way up to the universe as a whole. And that means you'll get to study fascinating systems like this. This is a quantum microscope image of an individual hydrogen atom. So you're actually seeing the electron orbitals around that hydrogen nucleus. And it can be very difficult to get a sense of just how incredibly small an image like this is. So I want you to just imagine for a moment that this stick person is you, and in their hand they're holding just a single human hair. And then imagine zooming like Ant-Man right down onto the surface of that human hair. And there you are, standing on the surface of that hair, and in your hand you're holding another human hair, and you zoom down onto the surface of that one, and across the diameter of that second hair, you can still fit about 10 of those images of the single electron orbital around this atom. And on these incredibly small scales, we enter the weird and fuzzy and wonderful quantum realm that we're still trying to make sense of in modern physics today, where the universe appears to become entirely probabilistic and behave very differently from the classical world that we're all familiar with around us today. So you'll get to study absolutely fascinating things like that, but you'll also be able to zoom out and study the entire universe. And that includes beautiful systems like this. This is the RS Puppis Cepheid variable star. It's a very special type of star because it actually pulsates, and it pulsates with a period of about 40 days or so. And it was discovered first by beautiful work by Henrietta Swan-Leavitt in the 19th century, that these stars, they actually pulsate. The rate at which they pulsate is proportional to how intrinsically bright they are. And so by measuring their pulsation period, you can estimate their intrinsic luminosity. And that means you can figure out exactly how far away they are. And with that, you can actually start to understand or see distance in the universe. And from that led to the discovery that, in fact, the entire universe is expanding away from us. And that led to the modern Big Bang theory of the cosmos. And this is a particularly beautiful example of a Cepheid variable star. This is lovely Hubble Space Telescope imagery, and this is real data, a real movie of the pulsating star. And you can see the ripples of light waves traveling through the surrounding reflection nebula. And that shows you that light travels at finite speed. On these enormous scales in the universe, you can actually see the light waves flowing through the surrounding gas. And using those ripples, you can actually get an independent estimate of the distance. And this is a beautiful calibration point for what we call the distance ladder, the ability to measure out to very, very galaxies way beyond our own in the universe. So these are just some of the things that you'll touch upon in a physics degree. It's absolutely, it's the fundamental stuff, that the laws that govern nature, and that's absolutely fascinating. But physics, of course, is also incredibly useful, that we use that fundamental understanding of the world, that basic knowledge, to build new devices, new technologies that actually change people's lives. Examples like this strained quantum well laser that was developed by Professor Alf Adams, actually here at Surrey. And you may not have heard of the strained quantum well laser, but it actually underpins a lot of technology that you see around you all the time in your daily lives, from barcode scanners to Blu-ray DVD discs. And it's now being used to develop new and ultra-efficient photovoltaics that can help combat the problem of climate change. But alongside devices like this that live all around us, we also have new technologies to improve healthcare. Things like proton therapy as a new and exciting treatment for cancer therapy. And there's an awful lot of physics that goes into making these machines work, improving them, making them work efficiently, and developing yet more exciting techniques for medical imaging and new ways of combating disease like cancer. So not only is physics, though, fascinating and useful, it will also help you launch your career wherever you decide to go next after a physics degree. And that's because you'll get a lot of transferable skills on the course that are incredibly useful in a very, very wide range of careers. And the fundamental one, I think, for physics is really problem solving. We'll teach you how to take a real world problem, turn it into a sort of a mathematical equation, or break it down into its most basic parts, solve that, and then be able to predict the behavior of these systems going forwards. And this is a tremendously useful skill. But alongside that, of course, you'll have numeracy skills, computer programming skills, presentational skills, team working, data science. And one of the things I think that's often overlooked is creativity. That like all disciplines, when you really become a professional and you're working at the coalface of that discipline, you're going to have to come up with new ideas. You're going to have to add to the canon of human knowledge on physics, and you'll have to be creative when you do that. You'll be generating the new theories, the new devices, the new technologies that will change the world, and that requires original thought and creativity. And so that can take you into a very wide range of careers, and Caroline will tell you a bit more about this later on in the talk, but just to give you a flavour, physics graduates often go into finance, they can become NHS clinical scientists, they can work in the IT industry, or in a massive growing offshoot of the IT industry, which is of course the multi-billion-pound video games industry, into defence and security. And yes, some physics graduates do in fact go on to become physicists as well. So an enormous range of possibilities, lots of doors open to you if you take on a degree in physics. So I'm going to hand over to Caroline now to talk a little bit more about what a physics degree is actually like, what's in it, what you'll be studying from one year to the next typically, and a little bit more about some admissions tips that might help you to get onto your favourite degree programme, and also a little bit more about exactly what kind of careers you can go into when armed with your physics degree. Thank you.
Hi, so my name is Caroline. I'm a lecturer in physics, but I'm also the physics admissions tutor for my university. So what I'm going to do is I'll tell you a little bit about what the physics degree content is like and what it's like to be a student studying physics. We'll then have a look maybe at the kind of the application process, and I'll try to share a few tips when you're writing your UCAS application. And then we'll end by having a look at some more of these kind of career paths and opportunities where a physics degree can take you. So first things first, you're looking for a physics department at a university. So things that you might be thinking about are, what size department would you like to join? Are you looking to be on a campus or a college-based university? Does the university have any particular partners that interest you that you then want to get involved and work with? And do you look for things like this TEF and REF? So these are kind of ratings, so teaching excellence framework and research excellence framework. And I'll talk a little bit more about them in the next few slides. So these might be some initial ideas that you're kind of thinking about when you're making your university choices. And on the left, I've got some photos. So universities are going to show you brochures and there'll be websites. So before you even visit the university itself, you can start to get a feel of the campus, the environment, what's in the department, and actually what it would be like to be a student studying there. Okay, so once you've had a quick look at the physics department, it's time to start looking in a little bit more detail. And so here we're having a look at the research interests of the academics that work in the physics department. So obviously I come from the University of Surrey, so this is a picture of the academics that are in my department. And the reason I'm showing this is because all of the academics will be world-leading researchers alongside being teachers and lecturers in their areas. And that means it can shape their research interests and what areas of physics they study. So when you're a student applying to a university, you may think, well, do I need to know about these research areas? Does it actually really matter what the academics are studying? And it really does, because in your final year, you might find yourself doing a final year project, and that most likely is going to relate to one of these areas that the academics specialise in. So in my department, we've got astrophysics, we've got medical physics, nuclear physics, photonics and quantum science, and soft matter and polymers. But that's just obviously where I work. You need to look at your university that you're thinking about applying to, have a look at their list. And if there's a particular research area in physics that you want to study, it's worthwhile checking to see if that department has it as one of the topics that their academics will be working on. And then you can go to the next step. So once you've had a look at their research, you can then maybe meet some of the staff, and we'll have a little chat about how you can do that, how you can attend open days. But alongside chatting to the staff, I'd also really recommend that you chat to current students. You know, there's some questions that you might want to ask about the course, module selection, and you might want to ask an academic member of staff those. But you might want to ask things about the campus, you know, the logistics of getting to the physics department, you know, how many hours a week are you studying in the library? And sometimes it's better to direct those questions towards current students. And then, of course, as well as seeing the department and seeing the academics and seeing the staff, you're going to need to have a look at the department and its facilities. And again, this is important. So if you want to use a particular piece of equipment, or maybe you're thinking about going into a particular area of research, you might want to check out whether the university has that particular area of science and equipment in their department. Okay, then, so league tables and affiliations. I've put up some logos here, so you may be familiar with these. So the IOP is the Institute of Physics, and you'll find that most UK university courses are going to be IOP accredited. And that's important because it means that their course has been checked and that the topics they're teaching and the breadth and the range of the material are going to cover the key areas of physics that will help you have the subject content to set you up maybe for your onward career. You're also going to see, as I said, this thing called REF, so that's the Research Excellence Framework, and that's kind of evaluating the output of research from that department. And then alongside the REF, you're going to have the TEF, and that's the Teaching Excellence Framework. And that looks at how well the academics are able to transfer their knowledge about the subject to the students. And so you'll see things like TEF Bronze, TEF Silver, TEF Gold, and that helps you give a feel for just kind of a rating that department got for how they share their information. Then you'll have things like the National Student Survey, and that's done by students, so you can see what current students on the course think. And then you might have other logos. So at my university, we're a member of SEPNet, and that's the South East Physics Network. And that means that the universities in the South East, we've formed a network together. So when we have students looking for summer placements, we can go across our network. We have industry partners within that network. And basically it allows students in those universities to leverage opportunities at industry partners throughout the whole network. And that's not just something that happens in the Southeast. You know, depending where you are in the country, there'll be a local network relevant to your geographical location. So what I would say about league tables and affiliations is they can be useful. So they can give you a useful indicator of how the department is. But maybe rather than just looking at the last year, if you want to get a real picture, it sometimes is worthwhile looking at the last 3 or 4 years worth of ratings so you can get a feel for that department. Okay, so that's probably enough about league tables and affiliations. So let's go back into the department. So when you're looking at your university physics departments, don't just look at the department, have a look at the wider university facilities. And yes, that might include going to check out the sports centre and the restaurant and the accommodation, but actually the physics department is most likely going to have wider technical university facilities as well. So again, my experience is from the Surrey side of things. So we've got an on-campus telescope, we've got a quantum centre, we've got nuclear labs, an ion beam facility, we've got a space centre next door to us, an advanced technology institute. And these are all things on the campus that are nearby. And that means that our students, when they're going through the degree programme, can benefit from some of these facilities. And so just check out the university that you're looking at and just see what they have, what connections they're connected to. Do they do a lot of work with the chemistry department or the engineering department? Do they have an external partner? So we're partnered with NPL, the National Physical Laboratory, but again, other universities will have other external partners. And this then kind of gives you a broader feel, not only of the department and the academic interests of the department, but also the wider faculty and facility that department sits in, and therefore the wider opportunities that you might get as a student. Okay, so let's say you've now down selected it and you've got a few departments and your list of universities is getting shorter. So now the next thing to check is, does it have the degree that you want to study, and which degree is going to be right for you? So you can study straight physics, and actually that's what I did. I studied for a straight physics and I did the MPhys qualification. But you can study for a physics with qualification or for a physics and qualification. So again, just a few examples. So we've got things like physics with astronomy and physics with nuclear astrophysics, physics with quantum technologies. And then at the bottom of this list, I've got physics and mathematics. And that and with is quite important. So the with means that you're going to do the physics degree, and there'll be some selected modules that you have to take. And if you take those selected modules, you'll get a physics with either astronomy in this case or nuclear astrophysics. If you do the and, so physics and mathematics, that is exactly what it says. You're going to be studying physics and mathematics. So some of your time will be in the mathematics department and some of your time will be in the physics department. And again, these subtleties are quite important because the physics with courses, or at least at my university, the physics with courses, it's fairly easy to move between them in your first year of studying. But because the combined honours physics and mathematics happens in 2 departments, it's actually a bit trickier if you change your mind and you want to switch course. So just keep that in mind when you're thinking about whether you want to do a combined honours, a physics with course, or go for physics, and keep your options kind of open to change your mind if you want to, if you can. And then when you've thought about that, you then need to think about, do you want to do the bachelor's course, or are you looking to do an integrated master's course? And I've got a slide coming up to show you kind of an illustration of the pathways between them. The bachelor's course can give you skills, subject content, physics knowledge. You then might want to go on after it and do a standalone master's 1-year course, or you might actually want to leave after your bachelor's programme and go and work in industry, go do a graduate scheme, start up your own company. So the bachelor's programme is giving you subject content knowledge, and it's giving you training and transferable skills. And then it sets you up to go on and do a further career in physics, or to take your skills and put them into a different discipline or a different industrial area. The integrated masters, that does a very similar thing, but it's kind of towards the end of that 4-year period, leading you towards a research type career. So that could be doing a PhD, it could be doing a year kind of a research placement where you're working in industry. So both options will give you subject knowledge and skills. So one might lead you towards a kind of a research pathway, possibly. One might lead you towards maybe a broader range of skills to apply to industry. But actually, they're both going to give you lots and lots and lots of useful skills. So don't make too much of a decision point here. And there are options to change between the bachelor's and the master's on some courses. And I will come to that in a minute. Then, of course, you might be thinking about starting with the foundation year. And so some universities will offer you a foundation year, and that actually comes before the bachelor's or before you start your master's. So what I'm going to do in a slide is I'm going to show you some of these career pathways and just how you can move through your university journey of studying physics. So don't be put off by the graphic. And again, just a reminder, this is an illustration of what happens at my university. Other universities will have different pathways, but it gives you the feel of what to look for when you're looking at your degree course options. So we have got 3 starting points here for our degree. We can start on the foundation year, we can start with the bachelor's programme, or we can start with year 1 of the integrated master's programme. If you start on the foundation year, it's most probable that if you pass that foundation year, you'll get automatically moved onto the bachelor's programme. So that step will just happen and you'll be able to progress onto that university bachelor's programme. If you pass the foundation year and want to change university and go to a different university to do your bachelor's course, you need to check their entry requirements, because universities will have their own entry requirements and they will look at the foundation programmes of other universities and set what they need from that course in order to go to their course. Then if you're coming in on the bachelor's programme, so you're entering year 1, you've then got a pathway to go to year 2 and to year 3. And that's your quickest way to come from starting your degree to qualifying and getting your degree certificate and leaving university. So that's 3 years of study and you end up with a bachelor's degree in physics. But you might find that the university you're looking at has some options. So an option at my university is to put in something called a professional training year. So here you do year 1 and year 2 of your bachelor's, but then you take a year out and you go and work with an industrial partner. And so where I am, that year is a paid year. So you get reduced tuition fees, you earn a salary, and you get to put your physics skills and experience into a job for a whole year. And that job could be working in a physics sector. So you could be doing something with your physics content and skills, but equally you might be taking your knowledge and applying it maybe into, I don't know, the finance industry, or maybe you're going to be working, doing some kind of energy related material and studies, or maybe you're going to be working in the education sector or the museum sector. And it gives you a chance to try out a career before then kind of going for it as your job when you finish your degree program. And in the case of this particular course, that training year doesn't actually count towards your degree grade. So it really gives you some freedom to try something and then be able to come back to your studies with more informed knowledge about what you want to do when you finish your degree. Of course, when you come back, you're then in your 4th year of study, but you're doing your 3rd year of the bachelor's course. So that's another route you could take. Then we have this route at the bottom in yellow, and this is our integrated master's route. So we've entered here in year 1, we go to year 2. Now, again, it's going to be specific on the university that you're looking at. Where I am, you don't do the professional training year if you're doing the integrated masters. Instead, you do something called the MPhys research year. And so this happens halfway into your 3rd year. You go out and you spend 12 months again doing research, cutting edge science, working for an industry partner or for an academic facility. And then you come back halfway through your 4th year and complete your studies. And the difference here is that that route, that research year, has a dissertation at the end, and then that will count towards your overall degree mark. So that is a really good route, doing these kind of research years, if you're thinking about, do I want to do a PhD? You know, am I wanting to do a PhD? Do I like this area of kind of research and study? Would I like to be a research scientist working in industry? After I did my PhD, I went off and I became an industrial-based scientist doing research before I came back to academia. So having these options to put placements in or professional training can be really useful. Okay, a little bit longer on this slide. People sometimes say, well, what happens if I start on the bachelor's and I do a bit and they go, oh, I really like to be on the master's course instead. Again, check this out with the university that you're looking to apply to, but we allow flexibility. So you can do the 1st year on the bachelor's course, and then if you're meeting the grade requirements of the university, we can allow you to switch over and do the integrated masters if you want instead. Likewise, though, if you're doing the integrated masters, we require you to meet certain grade requirements. And if you just dip below them, we transfer you across onto the bachelor's. So it's really worthwhile when you're looking at the university, look at the department, look at the research areas, have a look at the staff that are working in that department, have a look at the degree course, and more than that, have a look at the options and the flexibility within the degree course. Because again, if we're coming here from the BSc year 1 to year 2, if you are then thinking, oh, I started on straight physics, but I'd like to do physics with quantum tech, actually, we can change you in year 2 to being on a physics with course. And that's because all of our 1st year courses on the physics and the physics with programs study the same modules. So it's worthwhile looking in detail at the modules just to see what flexibility you're going to have on the degree programs that you're looking to apply for. Okay, I'll move off this slide now. Let's have a look then at year 1 in more detail. So here are some example topics of things you might face if you take year 1 physics at a university. Some of these ideas might be familiar. Some of these are going to build on things that you've been studying and learning up to this point. But what you can see from this slide is just the broad range of things you're covering. And that's because in your 1st year, it's really useful and important to get a grounding across the physics disciplines. So do some mechanics, do some work where you're looking at crystal structure, do some special relativity and look at kind of, planetary motion, do some mechanics and moving things into a rotational framework, have a look at energy, have a look at thermodynamics, because you might start a degree thinking, oh, I really love this area of physics. And then you might get to university and find that because the topic evolves, what's your favorite area of physics right now might change. And actually, you might have a different favorite area of physics by the end of your 1st year than when you started your university degree program. And so all of this helps then as you go into your 2nd, 3rd and 4th year, because this then allows you to pick modules that are going to interest you or maybe lead on to a career that there's one that you actually want to go and study and work in. So this is year 1. As a little feel, this is what the later years will look like, years 3 and 4. And what happens is year 1 and year 2, typically, we are covering the core parts of the physics course that we need you to know. So that's why you're going to get this grounding in the different areas that make up our physics degree programme. Then in years 3 and 4, typically you'll get more chance to specialise. So here you're going to see some modules that will be specially taught by the academics within the department. So we'll have people who specialise in astrophysics, and they'll be teaching things like cosmology and galaxy formation. People do soft matter and quantum physics, they'll be teaching courses that relate to their area of study. And this is great because as a student, you therefore get the latest information being taught to you by an academic who's working in that research area. And also in years 3 and year 4, and again, this is quite common across lots of physics degree programmes, you're going to see final year projects appearing, dissertations appearing, because often in those later years, all your training in years 1 and 2, learning how to use computational programming languages, learning how to work in the laboratory, how to use bits of equipment, then in years 3 and 4, you tend to focus those onto specialist projects, working in smaller groups, more closely with an academic member of staff potentially. So yeah, that's kind of like the overview of the topics. Again, it will be course specific. So most universities are going to put on their websites the modules that they're offering. So you can actually have a look at the modules. If you click through, you can often see the reading lists. So you can actually see quite a lot of detail about the course structure, the course content, and actually the topics that you would study if you picked that course. A little recap then about placements. Placements are something very useful that you can put into your degree. So alongside getting the skills in doing computational physics and analytical physics and understanding your subject and improving your subject content knowledge, you can also put in what we call these placement experiences, and that allows you to have some industry workplace experience to go onto your CV. So you can put them in across the summer. So let's say you're doing a bachelor's programme, you want to study for 3 years and then you want to leave the university, get in, study and leave. You might want to seriously consider putting in a summer placement. And you can look for these yourself. You can work with your university to see if they have any summer internships, or you can use networks and partners that university belongs to help you find a summer placement. So as I said, we're part of the SEPNet placement scheme. And so that means our students can apply to that scheme and they can look for placements across the Southeast. Then you should check out whether the degree course you're looking at has room to put in either a year abroad or a training year or a placement year. Does it come with a training year or a placement year as part of the degree? Because all of this gives you extra stuff to go on your CV. It will give you networking opportunities. You'll have other people who can write references for you. It might give you access to different bits of software. If you're working in a different country, you can see how somebody else in a different laboratory organises their research. Do they do things in a slightly different way to the way that your university organises its research? And all of this can really help strengthen your CV when you finish your degree and you're looking for either your next step in education or your next step out into your career. Okay, a little bit then about what it's going to be like if you're a physics degree student. This is a very typical timetable. You're going to find that physics is a high degree contact subject. So you'll be, working in the department or in a lecture theatre, probably about 20 to 22 contact hours per week. It's not all going to be lectures, so you'll see there'll be some lectures, there'll be some time where you're working in a laboratory. Laboratory includes experimental work and computational based work. Universities will teach you different computational languages. So again, at my university, we start you with Python, but different courses will choose different different computational languages to start you off with. One thing to note though, is you are going to get Wednesday afternoon free. This is traditionally so that we can have sports events. So one university can play sport against another event at another university. But also it's just really good for hobbies. If you've got a particular interest, if you play a musical instrument, it's a great time to do those kind of pastimes. But actually maybe you want to do your laundry or have a sleep. It's quite nice with a high contact hours subject to know you're going to have your Wednesday afternoon to kind of catch up with the week before the last couple of working days. And then wider than your timetable, have a look at the other activities you can take in as part of your university experience. So you're going to have things that are there to help you. So things like wardens and accommodation blocks, welfare centres, ambassadors, student representatives. Personal tutors are very, very useful. So a personal tutor is an academic member of staff who's assigned to each student, and they're there to help you as you go through your degree. So if you're thinking, oh no, do I want to change course? Do I want to do a physics with course? Do I want to look at particular module options in my 3rd or 4th year? You can chat to your personal tutor. And because your personal tutor gets to know you, they can then help write references for you when you finish your studies and you're looking for employment. Also, check out the Students' Union, check out what societies and clubs there are. Most universities, there's going to probably be a physics-related society. So ours is called PhysOc because it's the Physics Society. Now, this is a society that's run by students for students, and they do a whole range of activities. So you can find the students having quizzes, going on tours, having telescope nights, because we've got a telescope on campus, having balls. And the physics compartment at my university will chat and liaise with the PhysOc representatives, and we'll have some combined events. So at the bottom here, we've got this plate. The Alkalili plate is actually a football tournament that happens between the staff and student teams. And you might think, oh, why would I want to socialise with my academic, teachers? They just want them to teach me in the lecture theatre, and then I want to go off and do my own thing. But it's so useful to get to know your academic tutors, because at some point you might have to pick a final year project and you'll be working with an academic staff member. So not only do you want to know their research areas and their interests, it's also quite nice to get to know the staff a little bit, because it can help you when you're picking your final year projects. Okay then, so admissions tips. So I'm the physics admissions tutor, so I see UCAS applications when they come in. So not too many, but just a few tips that you might want to consider. When you're picking your university, make use of virtual tours. More and more universities now are putting up virtual material for you to have a look, to see inside the department, to see the subject areas, to meet the staff. So quite often you can have a look at that before you even visit the university. And then you want to consider the department, as I said, and the research areas. You can check out the social media. Universities will be on Twitter, they'll be on Facebook, and they'll be on YouTube. So do check out their social media. Think about the location. How far do you want to be from wherever you live right now? Are you going to be changing country? Are you going to be staying very local? And then have a plan B and a plan C. So you may have your heart set on a particular course at a particular university, but it's worthwhile working out a plan B and a plan C and getting those plans sorted before clearing. And I'll talk about that right at the end, but having those plans and ideas organised makes the whole process, I think, a little bit more, well, just calm. It makes it a calmer process to go through if you've thought about not only your plan A, what you would do in the ideal situation, but also your plan B and your plan C. And then, of course, nothing beats visiting. So if you can, do go visit the university and the department. Sometimes I think you need to go to the campus or see the university colleges to actually really get a feel about what it would be like to study there, and try to picture yourself there, because you'll be there for 3, 4, 5 years studying. And so you want somewhere that's going to feel homely and comfortable, and that you're actually happy to go back to each semester. Okay, and then when it comes to actually doing your personal statement, so just a few tips here as an admissions tutor. Think about what makes you stand out, and try to convey genuine subject enthusiasm for your subject. And then don't just say, oh, I really like physics. Give evidence-based examples. I really liked physics and I read a book by so-and-so and this particular chapter intrigued me. Give that admissions tutor some evidence as to why you're enthusiastic and why you particularly want to study that subject. And then if you can, also in your personal statement, link in some skills that you have. How are you going to cope with being at university? Are you good at time management? Have you had to balance activities at the moment? Does that mean you're going to be able to balance your studies with doing maybe a sport or a hobby? So these are all useful things to think about kind of putting into your personal statement. And then think about how you're going to make this flow. So you've got your interests, your subject skills, your achievements, why you're excited to study that particular course. Then you're going to try to give some evidence. So have you gone to a particular talk? Have you seen a TV program that sparked your interest? Have you read maybe an article or something in the newspaper that caught your attention? Is there some way that you can show that you're engaged with the subject and you're reading around it, or you're just interested in physics and the media and what's actually happening right now in the world of science? Then think about things that you've done. So have you got responsibilities at home, at school, in current clubs that you're a member of? Have you got any leadership skills that maybe you can include there? Have you had difficult tasks that you've had to tackle and you can show that you had a good strategy when you had a lot of deadlines maybe coming up at the same time? And then think about how you're going to make this whole thing flow together into your personal statement. And I think sometimes it's quite hard just to get writing. And so don't feel like you have to get it perfect the first time. Get your ideas down on the page and then think, okay, do I have a strong opening? Have I immediately shown that I'm keen and I'm excited to study that course? Is my middle section loaded up with evidence and interests and skills and qualities that show that the course is going to be a good match for me and I'm going to be a good match for the course? And then at the end, do I bring up me? Do I show the things that make me who I am, why I'm unique, and why I want to study at that university? And if you can, try to get your opening to link to your ending. So yeah, personal statements I think can be quite tricky to write. The best tactic is just to jot your ideas down. And then once you've got something on the page, it's much easier to move it around and to get it to flow in a way that you're happy before you send it off. Then make sure you know the UCAS process. So the UCAS website's got loads of information about the key dates, how you move through the system, things like adjustment. So do you understand adjustment? Do you understand how the track process works? Then look at the program that you're thinking of studying and say, okay, well, what grades do I need? And are those grades subject specific? So sometimes for physics, you might see there's a subject specific grade on both the physics and the mathematics. And you might see that we have different grade requirements depending on which course you're looking to enter. So if you're looking to enter on the foundation year or the bachelor's program or the integrated master's course, they are most likely going to have different entry requirements. And then you might want to talk to your university admissions tutor about, well, what happens if I miss those entry grades? So where I am, if you miss your MPhys grades, so you applied for the integrated masters, but you missed those grades, if you miss them, but you have the grades for the bachelor's course, we will automatically make you an offer on the bachelor's program. And that's because actually we know that you can move back over onto the master's program if the first year of studying at university goes well and you want to make that transition back again. But if you say applied for the bachelor's course and you missed your grades, we can't put you onto our foundation year because UCAS handles those as separate courses. But what you can do if you wanted to, say you really liked university and they had a foundation year, it might be possible to use the foundation year as your insurance choice and to put either the bachelor's or the master's as your firm choice. And that way, that can give you a broader range of grade requirements to get into the university that you're interested at studying at. So do check that out. Do check what happens if you miss your grades. Does the university have a foundation year? Will they move you automatically between one course and another course? Some universities are going to require you to have an interview before you get offered a course place. They might give you practice materials. There might be some notes online that you can have a look at before attending that interview. The UCAS adjustment, that actually happens during the clearing. So let's say you do your grades, you pick a university, but then you get better grades than you're expecting. You then might want to reconsider your options, and clearing and the adjustment process will let you do that. So that's worthwhile having a read up on. And in general, just being clearing day prepared. You want to wake up on the morning of your results release day, knowing what your plan A is, but then having the telephone numbers and the contacts for the universities if you need to go down your plan B or your plan C. So if you miss your grades for the physics course, are you going to swap to a physics course at another university? Are you going to take a gap year? Would you consider changing subjects slightly? It's useful to think about all of these things before the results release day and to get the telephone numbers ready. So you're not having to look them up on the morning the results come out. You've got your telephone list and you're ready to go, so you can start calling around universities if you needed to. And when you do, and if you need to make those phone calls, be very clear what you want to study, because you may have signed up to do physics and then somebody might say to you, oh, actually, rather than doing physics, have you thought maybe about doing this branch of engineering or computational physics? And it might be right for you to change onto that alternative degree program, but equally you might say, oh no, actually I really do want to do physics, and you might decide to either retake your exams or take a gap year, or maybe just pause your studies and have a reflection period before deciding what you want to do next. So yeah, have that plan B and plan C and be clearing day prepared, and make sure you've got your relevant emails and phone numbers to hand. Okay, so very finally, you've thought about doing physics at university. I mean, I think it's a great degree course. I thoroughly enjoyed doing physics. When I did my physics degree, I did the master's course, then I did a PhD, and then I left academia and I went and worked in industry for many years. And then I came back and now I'm a lecturer and the admissions tutor. But career paths, so these are all people that you might know from media. These are all people who've got a STEM background, so science, technology, engineering, or mathematics. So just because you study physics, it doesn't mean you have to be a physicist or indeed a scientist. There are many options open to you. And as Justin said at the beginning of this talk, you have so many transferable skills, analytical skills, creative problem-solving skills, essay writing skills. So these are all highly desirable skills and attributes that employers will be looking for. And just as an example, why study physics? Well, these are PhD destinations in non-academic careers from the years 2016 and 17. So these are students who studied for a PhD, completed their PhD, and they decided not to go into an academic career, but instead to pursue a career either in business technology or engineering and mathematics or finance or health or law. So you really do have a wide range of options open to you when you finish studying on a physics degree programme. And my final slide just will show you some of the options that you have. There are too many to fit onto this slide. You can have things working in the medical sector. You know, you can build equipment for hospitals. You can be somebody who analyses stuff if you go down maybe the NHS pathway. You can go work as a computing gaming specialist, design new technology for the engineering sector, work in scientific computing, the defence sector, the retail sector. Go work in teaching. You can work in teaching in all levels. You know, maybe you want to go for the very young start of their career children. Maybe you want to go and teach at a degree level type course. Maybe you want to go on and pursue a career as a physicist. So you want to be a research fellow or an industry scientist. Perhaps you really like science, but you actually want to work at a large scale facility. So you want to go and work maybe as a beamline scientist somewhere, helping other scientists perform their experiments. Maybe you want to go work in marketing or technical sales. There are just so many options. So I'm really pleased that you're interested in studying physics. I hope this presentation was helpful and gave you a little bit of a feel about what it would be like both to be on the degree course and some pointers maybe to help you pick your university and which degree pathway is right for you. And then at the end of all this studying, you're going to have all these career options open to you. So good luck in your future degree and your future studies. And I hope this was helpful. Thank you.